So planning and conducting an investigation. That's what we're going to look at in this lesson. So in this section, we will look at the following learning outcome. So by the end of this, students should be able to design, plan, and conduct investigations. Explain how reliability, accuracy, precision, fairness, safety, ethics, and the selection of suitable equipment have been considered. So it's really about kind of the nuts and bolts, if you like, in relation to carrying out an investigation. So I'm going to get you to take this particular question. Does adding salt to water affect the boiling point of water? And you're going to plan an experiment. You're going to carry out the experiment and you're going to answer that question scientifically. So does adding salt to water affect the boiling point of water? So we have to think about what do we mean by boiling point? So water is a form of what's known as matter, and matter can exist in different states. So it can be a solid, a liquid, or a gas. So if we take water, we're probably more familiar with water being in a liquid state. If you freeze it, it will become solid, it'll become solid ice. If you heat it up, it changes from a liquid to a gas. Now, in order to heat it up, you have to add heat energy to it. And heat energy, we can measure it using degrees Celsius. So for example, you'll often hear, if it's a hot day, for example, it might be 30 degrees Celsius. So this is the unit, if you like, that's used to measure temperature. And we can use one of these guys here, which is a thermometer, to measure temperature. So basically the boiling point is when we add enough heat energy to turn the liquid from its liquid state into a gas. So it's the temperature at which water, for example, the boiling point is the temperature at which, in the case of water, it turns from a liquid into a gas. And temperature, and that's kind of like what we say is the liquid is boiling, so it's changing state. It's going from a liquid into a gas. And the boiling point of water, which you probably know, is 100 degrees Celsius. So that's the temperature. So you have to get it up to that temperature in order to turn it from a liquid to a gas. So think when you boil the kettle, for example, how do we know the kettle is boiled? We know because it starts to bubble. And what's happening is the liquid is starting to turn into a gas, and you can see steam or hot gas coming out of the top of the kettle. And then what happens is there's a mechanism in the kettle that switches it off, and you have boiling water. So if you were to take a thermometer and put that thermometer into the water and measure the temperature of the water, it would be 100 degrees Celsius. So what we want to see is, if we take salt and we add it to water, will that actually change the boiling point of water? So will it increase the boiling point? So for example, you'll need to heat it up to above 100 degrees, or will it actually lower the boiling point? So you might start to boil, for example, change from a liquid into a gas at 90 degrees or 80 degrees Celsius. So that's what you're going to investigate. So again, in order to investigate a question, so this is a question that's appropriate for scientific investigation because we can actually come up with a way to test it. So if we take this, we can change it into an if-then statement. So for example, an if-then statement is where we get very specific about the question and what we're trying to answer. So we can say, if I add 50 grams of salt into 500 mils of water, then the boiling point of the water will reduce below 100 degrees Celsius. So this is an if-then statement. If I do this, then this will happen. So some of the things that you're going to have to take into account when you're designing this experiment, you're going to have to think about roughly how are you going to do it, and then you're going to have to think about what are some of the things I need to take into account when I'm designing the experiment. So one thing that you need to take into account is, so for example, you're going to have to weigh out 50 grams of salt and measure 50 mils of water. So you're going to have to use instruments like these two guys here. So you're going to be using a graduated cylinder. So this is what's known as a graduated cylinder. And a graduated cylinder basically has graduations on it, and it allows you to accurately measure out a volume of water. And also as well, you're going to have to measure out 50 grams of salt. So again, you're going to use a balance. So when you're using when you're making measurements, for example, of volume and weight, it's very important that volume and mass, should I say, it's very important that your measurements are accurate, that you check and see exactly how you're measuring it. When you're using any kind of volumetric flask, what happens is, like this, for example, like a graduated cylinder, basically the water, the level of the water bends, and you have this bottom line here. So when you're measuring, you always measure from this bottom line, which is known as the meniscus. If you measure, for example, up here, your measurement will be inaccurate. When you're using a balance, it's very important that before you weigh anything on the balance, that you zero it, that the balance is set to 0, and then you get your weight. So before you measure your salt, for example, you will need to what's called zeroing the balance. So in order to kind of carry out this experiment, so you'll need a thermometer. So you'll need to kind of set up like this. So you'll need a beaker to contain water. So you'll have 500 mils. You'll need a thermometer to measure the temperature. You will need some kind of heat source. So for example, a Bunsen burner. And you'll need to be able to heat the water. So you'll have basically two kind of investigations. So one investigation, you will just have water in it. So you're not going to do anything with the water. You're just going to use all the same instruments and same amount of water, same type of beaker, same type of heat source, same thermometer, and you're going to just boil it. And this is what's known as a control. And basically what you will do is, this is like a baseline. So you use this then to compare your experiment to. So this is what's known as the control. So your investigation then is going to be the water with the 50 grams of salt added to it. So you're going to measure the same amount of water, measure 50 grams of salt, put it into this beaker, and you're going to again heat it up and see and measure and see how, like, what temperature does the water start to boil at. And then you can compare these two to each other. So this is water with no alteration to it. So you'd expect it to boil at 100 degrees. And then this is your experiment or your investigation. So this is same amount of water, but with 50 grams of salt added to it. You're going to heat it and see, does it boil, for example, above or below the boiling point of water, which is 100 degrees. So that's your kind of investigation. That's what you're going to carry out. So this is so we're taking our question, we're turning it into a hypothesis. So remember from the last lesson, a hypothesis is basically a question that can be tested out to see if it's true or false. So you're going to design an experiment, and I'm going to give you a handout which will give you some of the details of this. But again, this is something that we've used previously as well in previous lessons. I'm going to get you to design your experiment. So this is like roughly everything that you kind of need in order to carry out the experiment. And then these are the kind of things that you need to take into account when you're designing your experiment. So you have your question, you have your hypothesis. So it's the question put into the if-then statement. You clearly state what your prediction is. So for example, we predict that it will actually lower the boiling point of water. So what are you going to change? So for example, if we take, so we're going to have, what are the things that we're going to change? In one beaker, we're going to have the same volume of water with no salt. In the other beaker, we're going to have the same volume of water, but with 50 grams of salt. So that's something that we're going to change. What are you going to measure? So we're going to measure the temperature at which the water boils. That's the measurement. What are you going to keep this? So what are you going to keep the same? So we're going to keep everything about the two experiments the same. So for example, we're going to use the same type of beaker, same type of thermometer, same heat source. We're going to use the same volume of water in both, and the thing that's just going to be different between the two is one will have 50 grams of salt, one will not have 50 grams of salt. So these will be your control and your experiment. So then you're going to kind of draw like a label diagram, if you like, of the equipment that you're going to need to use. So for example, it's pretty much what we have here. So the method, so for example, so your proposed method and the procedure in step format. So so you have a rough idea of what you're going to do, but you need to break that down into a step-by-step procedure. So step 1, step 2, step 3, step 4, step 5, step 6. And you're going to also need to take into account things like safety and some of the other features of carrying out an investigation that I'm going to talk about now in a bit. And it's also a labeled sketch of the proposed procedure as well. So this is kind of like a comic book, like step by step by step, but it's like a labeled diagram of each step. Then you need to think about like what kind of a table would you need to construct. So we're measuring temperature, that's what we're going to look at. So to capture your results, and then you need to think about like how are you going to present your results. So for example, is it possible to put your results in as a diagram? Can you use like a pie chart or a bar chart or something like that? How are you going to actually present your results? So these are the things. So this is an investigation that you're going to carry out, and it'll kind of give you an idea of what's involved in preparing an experiment. So when you're going through this planning phase and creating your experiment, these are some of the things that you need to take into account, and this is what we're going to talk about now. So the first thing that's really important in any science investigation is these two qualities of what's known as reliability and accuracy. So when we carry out an investigation, we don't just do it once and accept the first result. So for example, you will carry out this experiment, for example, at a minimum of 3 times. In order for the investigation to be reliable, we need to get at least 3 test results. So we need to kind of carry out the experiment at least 3 times. So you don't just do one experiment and then just accept your first result, because something could have been altered, or you could have made a mistake, or something could have went wrong. So what you want to do is you want to do it at least 3 times, and you want to then get an average of your test results. So for example, you're going to look at how adding salt to water affects the temperature in relation to the boiling point. So you're not just going to end up with one, like you're not just going to do it once and measure the temperature once. You're going to do it 3 times and then get the average of those 3 results. And accuracy, you can think about accuracy, it's how close the result is to the true value. So for example, we're humans, we make mistakes. So if we just do the experiment once, there's a high possibility that we could have made a mistake, and that might not be like a true reflection of the truth or the actual result that like what actually happens. So a way you can kind of think about this, so you can think about reliability and accuracy. So reliability and accuracy is, so reliability is how close repeated measurements are to each other. And accuracy is how close a measurement is to the true value. So you can think about this like if you just think about a bullseye, for example. If we look at the first one here, so this is, for example, the shot is accurate and it's reliable. So you can see that it's hitting the bullseye, the target, okay, so that's right in the center. But also as well, you can see that the method that the person is using is very accurate. Why? Because the results are very much the same. So for example, if you were to carry out your experiment and 3 times you got, let's say it was 90 degrees Celsius, and like the 3 times you carried out the experiment, they were all within, let's say 90 degrees Celsius. You can say then that you could say that your experiment is accurate and reliable. That is if, for example, 90 degrees is the temperature at which adding that amount of salt to that amount of water reduces the boiling point. Another one here is, for example, the shots are accurate, okay, but they're not reliable. So for example, we can see here that the shots are kind of spread out. And that same thing can happen with an experiment as well. So you can get results that are kind of close to the true value, but there's a lot of spread between the results. So the results could go from, for example, if the true value was 90 degrees, you could be getting results that are, let's say, between 80 and 98 degrees. Okay, so there's a wide spread there of your results. So that indicates that although it's fairly accurate in relation to the true temperature, it's actually unreliable because all of the results are very different from each other. So it indicates that the procedure wasn't carried out exactly, the steps were not followed exactly the way they were, but there's some kind of difference between how the experiment was carried out each time. The next one then is this is inaccurate but reliable. So for example, you could get a result that's way off the true value, but all of the values you get are way off, but they're all very close to each other. So that indicates that it is a reliable, like the procedure, the way the person has carried it out is very reliable because they're getting the same result, but there's something going wrong because they're getting the wrong result. And the next one then is where it's completely off the normal value, the value that you would expect, and it's also inaccurate. So the values are not very close to each other; they're very far away. So these are the kind of scenarios that you can get into when it comes to carrying out scientific investigations. So what are some of the ways that improve in reliability and accuracy? So we can improve reliability and accuracy if we have a step-by-step instruction and follow it exactly every time for the investigation. So you have a procedure and you follow that every step by step by step. You carefully measure and record each measurement. So for example, you don't just guess, like when it says 500 mils of water, you measure out exactly 500 mils. When it says like 50 grams of salt, you measure out exactly 50 grams of salt. So you don't guess, you use the tools in order to get accurate measurements. You repeat the investigation at least 3 times, so that gives us a sense of reliability. So do things like zero your balance, and use good equipment and materials as well. So these are some of the kind of things that you would do in order to improve reliability and accuracy. So again, reliability and accuracy, never guess a measurement, take the time to measure it carefully. When measuring volumes of liquid using a graduated cylinder, read from the bottom of the meniscus. So when you're using a graduated cylinder, you'll notice that the water kind of bends like this. So this is what's called the meniscus. And you take your measurement of the bottom of the meniscus, not up here, but down here. And when using a balance, so you're going to be using a balance to measure the salt, make sure that the balance is zeroed. So these are some of the ways that you can improve reliability when you conduct an experiment. And it's the same for when you're reading, for example, the thermometer as well. Make sure you read it accurately, that you look at it and see exactly where the level of the thermometer is, and you record that result accurately. And again, it goes the same for any other type of procedure that you follow. Follow the procedure exactly. Carry out the investigation exactly as the way it is laid out in the experiment, in the procedure. So the next thing you need to kind of take into account is precision. So precise results are ones where the data is close to the mean result. So for example, when you're carrying out your investigation, you're going to carry it out 3 times and you'd expect those results to be pretty much the same each time. So if they're the same each time, that indicates that your method and the way that you're carrying it out is precise. If you, for example, you carry out the experiment 3 times and you get 3 totally different temperatures, then that indicates that you're doing something wrong, that there's a lot of variation in your procedure and your results are not going to be very precise. So precision is something that you really need to take into account. And then the last kind of thing then is like safety, fairness, and ethics. So again, from a safety point of view, so always wear your lab coat. So like what are some of the main kind of hazards that you can come up against? So fire, chemical hazards, and broken glass. Always wear a lab coat and safety glasses. Tie your hair back. So if you're using a Bunsen burner, make sure your hair is tied back. While heating the test tube, or if you're heating, for example, the beaker, point it away from yourself and others. Never leave a Bunsen burner unattended when lit, and always use a yellow safety flame when not in use. So when you're not using the Bunsen burner. So from a chemicals point of view, always wear lab coats, safety glasses, and gloves. Long hair must be tied back. Using a well ventilated room, so we're not going to be using too many chemicals in this. Be familiar with the safety labels on containers of chemicals, and always report spillage to your teacher as well. And then broken glass, so for example, if you drop a beaker and it breaks, always wear a lab coat and safety glasses. Always report broken glass to your teacher. Never handle broken glass with bare hands, because you're going to get another glass stuck in your hands. And always clean up broken glass with a dustpan and brush. So if you break something, just let us know and we can get it tidied up. The last thing you want to do is just leave it there and then somebody else could come along and get a lump of glass stuck in their hand or sustain some kind of an injury. So that's safety. So the other thing you need to kind of take into account as well is fairness and ethics. So fairness and ethics. So always carry out the investigation using a procedure. Do not skip steps. Make careful measurements. Do not make up measurements. So for example, if you're struggling for time, you might just say, oh, okay, well, I'll do the experiment once, and then I'll just guess the other measurements. So don't do that. That is what's known as, it's unethical. Consider safety before carrying out the investigation. So these are some of the kind of main safety things you need to take into account. Identify and use suitable equipment. So the equipment that you use, like, inspect it, have a look at it, make sure it's up to, like, it's not damaged or broken. And by doing this, what you will ensure is, this will help to ensure that the investigation is safe, that it produces a fair result. So for example, if you have an experiment and you make careful measurements, you can say that the result is fair. Okay, so that it's a fair test, and that you follow good practice as well. So in relation to making your measurements, zero your balance, and make sure when you're reading the measurements of a graduated cylinder that you're reading at the bottom of the meniscus. So that is some of the kind of main things that you need to take into account when putting together an investigation and then going about and carrying out an investigation.